Right, let's take a look at this problem. Code schedule 2. There are a total of number of courses. Okay, it is parameter courses you have to take, labeled from 0 to n minus number of courses minus 1. You're given an array prerequisites where prerequisites I is equal to I and AI, A, B, I, indicates that you must take the course B first if you want to take course AI. For example, the pair 01 indicates that take course 0, you have to take course 1, right? Return the ordering of courses you should take to finish all the courses. If there are many validances, return any of them. Alright, if it is impossible to finish the course, return an empty array. Alright. So first thing that comes to my mind is to convert this two arrays into actually one array into adjacency, or like dictionary with like adjacency list, something like that. So I need that because I need to, like, it would be nice to access all possible requirements of a course in instant time, so all of one time. So for that, I'll just go through every requirements in prerequisites, and every time, so I require to, so course requirements here. So I'll create a dictionary of that. So if course is not in my dictionary, then I want to create I want to just initialize it like this. Just 1 second. Right, I'm back. So I just initialize it like this, and after that, since I have it, I just want to append that list, the requirement of that course. And at the end of this, we will have a dictionary with lists. Dictionary keys are the courses, and the values are the value of that key as a list of requirements for that course. And using this, I will be traversing over this graph because I can it represents a graph here. And if we have a cycle, if it is not possible to do it, we have a cycle in that graph. And to detect the cycle in a graph, then I will have a recursive function to detect this. And if it is possible to do it, then I'll just return what I have. So I'll need a just cycle, or like order, like find order function that will take or I actually want to graph. I want to name this graph because it's a graph. I will like a graph. I'll pass the graph. I don't need to pass the number of courses there. I have to pass the visited and a visit thing. All right. Yeah. I will be using visiting so that in those cases where I visit, like in that current recursion, if I'm visiting something and I come back to the same thing, then I have a cycle. It means that I have a cycle. And in that moment, I just want to return false, like if it means that there's like a cycle. So if the, so I also have to graph my current like course here. If course is in visited or like visiting, then I just want to return true, which means that there is a cycle. And for every neighbor of that course, current course, so by the way, yeah, I'll call that function, it's wrong. So every neighbor, I'm gonna call it n in, yeah, neighbor in graph. So I will use my hash table here, course. So I have the list. For every neighbor, I want to go over it. First, I have to mark it as visited. So visiting that append my neighbor. And I also want to remove it, visiting. So let's see, I'm currently, actually this is wrong. So I just place it here. I'm currently visiting this course, and here, so I am currently visiting this course. I mark it as I'm visiting. Then I go to neighbors, and let's find order of neighbor. I pass the same graph. I have passed visited. I pass visiting. And if it is in visiting, then it's done. And also, if the neighbor, or yeah, instead of that, I can just put it here. So if course is in visited, I just want to stop there. I don't want to go beyond that point because I already visited it. So I just return here, and after this, I just, so visiting that pop, I just pop it from the visiting and I add it into visited core, because it means that we are done with this inner recursion, inner like tree, subtree, or solution space below that course. And when we are done with it, we just pop the course and append it in the visited, because we are done with the inner traverse. And it means that we, so here, that if cycle, so if there's a cycle, there's no cycle, it means it just false. I don't do anything. If there's a cycle, return true. So if there's a cycle here, it means that like there's a cycle. And here, if there's a cycle, I just return true immediately. I don't want to continue. I just pop it. I don't even want to pop it. I just return there. And here, if find order, I will start with the first course, and I will pass the graph and visited and visiting, which are at the start, they are equal to empty list. So if this returns true, then I just return that, and else I just return the results. Yeah, and to hold the results, I also need a result here, where I have my path. Like this is actually the path. I mean, it doesn't matter. I'm just gonna name it results. So here, when after this point, like at this point, if it is visited, so if I visited every possible, if I add it here, it means that there is no cycle. I visited it before, and yeah, after this, after I append, let's see, means that it returns false, and here there's a way to do it, and I want to append it to there. So resulted append visited. Yeah. Let's see. I forgot to pass the results. It returns empty, right? What is this? 0. I made a mistake there. It starts from 1, right? What's the number of courses? 1. Yeah, again, small mistake there. I and me, they cannot be equal to each other. So here I also forget to pass the result. Again, I'm passing 0. What is this? This is number of courses. It should be course in neighbors. What is this? Prerequisite. Wait, what is this? Course 0. I'll just append that. I'll put it like the here. Like this. I don't understand. What is this? Number of courses. Oh, no. The courses start from 0, right? It's 0 indexed. Okay, so why do we have a problem here? Let's print the graph. This is 1 0. What is my input? Oh, I forgot to oh yeah. I forgot to add that one. So here I need to add every possible yeah, instead of this I'll just, so for every I in range num courses graph I is equal to empty. Okay. Okay, what is expected here? Let's print the visited. Maybe I have to copy this at that point. Okay, I start with 0. So I have to go over for every I in range num courses So this is I here. So I have it. So I should find the start here, and if graph I is not empty, let's print I number of courses. At one, I just go in, go down there. You see, so my graph is 1 require 0. 1 require 0. That's the requirement. I have to do that 0. 0, I don't have to do anything. If 0, if the course visiting, course and visited. No. So I just append it here. If the graph instead of this, if the graph course right visiting we just go in. So just after this, right? So output print visited. It should be visiting, right? I should have it here. Let's see. Now it should be like that. And reversed. thing there, and then return. I reverse it because what's my output? Um, for every I in so if I have like this, maybe I just return this here if it's empty. If not, return that. Here, instead of false, I'll just return result. I don't need this. I don't need that. I don't need that. I don't need that. I just come here, result is here. I'll just return that. So that is not empty. Because of that, I'll just not empty. It won't go in this. I'll just go out of this and we'll have a invalid syntax. Yeah. Okay, fine order list return strange. I also could do like this. I made a mistake there. So for every item 4, item in visiting -1. Let's see. What is this? I'm not sure. Maybe put it here. Now return results. Oh, wait. Yeah, that was correct, but I just have to put it here. My list, if list length of, if not list, that is empty. I just return this. Else, also return. Maybe just return the visited here. Yeah, I'm a bit confused here. So here it says true. Cycle, if there's a cycle, I just return true. Here, else. False, there is no cycle. Just continue like that. I just return the visited. There. Visited. What do I have here? Let's see. But at this point, yeah, I have to. Yeah, I'm having problem with the output. I think it is working, but let's say results. I have a result like this. Again, I want to append it here. I put it here and here. Let's append visiting. And yeah, here. If this is true, then that else return result 0 maybe. But we also have to reverse it, right? Put it here. Now it is 1. Okay, now it's working. Let's test it with different cases. I have 4 there, these values here. It's not working. How many minutes? 30 minutes. I guess I just go over everything like this and return results. Go over every course. If visited, if course and visited, then return false. Okay. So see this. I have to do all this. We start from 0. We just go to zero, 1, 1. You have to go to 0. So that's 0. I visited 0 at that point. Now, so you can just go to 1. You just put it in visit thing. Should have like 0 there. 0. I don't know why this is taking too long. Okay, if it is so if you're currently visiting it, then we just return true. But if the length of number of courses visited, if it is equal to if I haven't visited it, I don't need this. So I mark it as visiting. Yeah, I think I should just put it here. Mark it as visiting, then I'll pop it there. I have visited here. Let's try this now. Let's see. Now I just go to 0. I just take it because yeah, I have it there. I can go to 1, and then I can go to 2, and then I can go to 3. So visited, and at the end my visited is current I don't even need this. Okay, let's try the other one. Okay, let's see. What is this? Wait, I just tested that. 1 0. Later it returns empty. Yeah, I should have a like if graph I and that. If we don't have it in, like if you don't have requisite for that, we just don't go there. Let's see, if graph I 0. Actually, wait, if not, if I have something in there, if it is not empty in there, right? So, wait. Okay. At 0, why are you going in? At 1, I don't understand, like, why is this? What? Oh, wait. 0 and 1. Oh, it will be wrong. Oh. Oh wait, yeah. That 1, so 0 1, and 1 is not visiting, it's in visiting. No, it's not in visiting, I just come here. It's true. Wait, what? What am I? I guess I'm not going in this. So I just at the end of this, I'm just returning false. Like, so visited. You just visited that, right? And next, and wait, what is the visited here? Here you don't. You just want to return visited. I'm pretty confused here. Right now I'm just say that this is 1 0 1 2 1 0, and I also want to test this. And here it should be 4. So now I'm always returning the result. Why am I appending to it? I don't understand. Let's see if it works. Okay, yeah, I guess I'm a bit tired right now. So, what's the complexity here? I'm gonna clear this out. What's the complexity here? The space complexity is, of course, time is of n, spaces of n, because I'm holding all the path there. This is the number of courses. This is the number of actually courses and prerequisites. Yeah, I'm holding them like that. Requisites. And the time is, so we go in, we call it for every neighbor if it is not visited. So if we visit everyone just once, so it is just we just visit every, like, for every requirement, every possible. Yeah, I think it is just n often. If it is equal to that, we'll just stop. So it is of n. Uh, I think so. I just have to check the complexities. Here, let's take a look at this. Complexity of BFS E plus E. So yeah, so this is plus requirements. Space complexity will be still same. We have adjacency list, right here. Let's see. Because of the adjacency list, it is plus the requirements again. Yeah, I should practice more on the complexities. So this is depth first search on the graph with the number of edges is R and number of vertices is the courses. So alright, I'm just gonna close now. I'm a bit tired.